All right, guys, welcome back to day 3 of exponential functions. Today we are going to be talking about more exponential functions, and specifically we're going to be talking about Euler's number and how to solve for time in our exponential functions. All right, so let's just start up with a quick warm-up just to remind us of how to set these things up. So if you remember, all of these are going to be in some form of y equals a times b to the x. So if you imagine, suppose you invest $1,000 in stock that had been steadily increasing by 15% each year. So A here is going to be my initial amount, which is 1,000, times my multiplier. And so remember, to get B, I need to take 100%, add 15% to it, and I get 115%. So my multiplier is in fact 1.15 to the x. Okay, and so then to find out how much I have after 6 years, you just take out your calculator and you do 1,000 times 1.15 to the 6th power. And let me do that real quick in my calculator. And I got that you would have $2,313 and about 6 cents. All right, so you'll notice that I asked a second question here. Calculate how long it will take to double your money. Now, before we did in the past, we just estimated and guessed and checked a lot when it came to solving for the time. But today we're going to learn how we're going to use our calculators to calculate the exact time that our money is going to double. So if you imagine, if we double our money, okay, and we started with 1,000, that's telling me that I have $2,000 in the bank. So if I set 2,000 equal to my equation, this is what I get. So 1,000 times 1.15 to the x power. Okay, so I'm ultimately trying to solve for this x value right here. All right, so the first thing I'm going to do is I'm going to divide by 1,000 on both sides. When I do that, I get 2 equals 1.15 to the x. All right, so as of right now, you guys don't know how to solve for an x value in the exponent. So today is when we're going to learn. So what I'm going to do is I'm going to do something called a logarithm. Okay, and I'm going to do a log of both sides. Now, remember that we talked about inverses in this unit as well? Okay, and so the log is the inverse of an exponent. Okay, so that's why they undo each other. Okay, so that's why this works. So this is what ends up happening. What this looks like is I have the log of 2 equals the log of 1.15 to the x. Now, and I'm going to move some stuff real quick just so that we can have more room. So what logs allow us to do is I'm going to divide by log of 1.15 onto the other side. Okay, and so what I get is I get log of 2 divided by log of 1.15 equals, and then the only thing left over here is x. All right, so what we're going to do, and I have my calculator here to kind of show you how this is going to look. To type this in, you're going to hit log, which is right here, okay, on your left-hand side. You're going to hit log of 2, and so it should say something like this in your screen. Okay, log parenthesis 2. Okay, and so then you're going to have to make sure that you hit the close parentheses, which is right here on your keypad. Divided by, okay, so you hit your divided by sign, log of 1.15. Okay, and so if you hit enter, that spits out x equals 4.96. This is the exact time. So if you imagine this was measured in years, so 4.96 years it would take me to double my money. Okay, so that is how we will always solve for time, by using logarithms. Okay, again, if this doesn't make sense, if you can't find it on your calculator or get the same answer as me, make sure that you call me over and I can certainly show you how. Okay, so like I told you, we were going to talk about Euler's number. Yes, this guy's name is pronounced Euler. And we're also going to talk about natural logs. Okay, so we did logarithms in the last slide, and now we're going to talk about natural logarithms and how they help us with solving things with e involved. So if you remember on your assignment, there were things with e that I told you to skip until you watched this video. So now we should be able to do them after watching this. So e is kind of like pi. It's equal to an irrational number that does not end and does not repeat. So if you remember, pi is like 3.14159, etc., etc. Okay, e is in that same class of number. Okay, so we're going to have equations, exponential functions, that are y equals e to the x. And so to undo those, you have to do a log base e of that number. And so if you'll notice on your calculator, right below log, okay, so there's a button that says log. Right below that button is a button that says ln. Okay, so that ln is specifically for when we are using e as a power. Okay, so we'll be using that a lot when we talk about e. All right, so let's talk about first the equation that we're going to use when we use e. This is for continuously compounded interest. So if you remember, we talked about compounded interest a lot in sequences. We talked about monthly and quarterly and all of those different ways to compound. Okay, this one is going to be a continuously compounded interest. So if you think about compounding interest every second, this is actually even faster than that. Okay, so it's continuously compounded. It uses a times e to the rt, where f of t is the total amount earned after the equation is put through. A is the principal or the starting amount. Okay, r is now the rate. It's going up in the exponent with the t time in years. Okay, so again, with all these formulas, you just need to be subbing in what you know and solving for what they ask you to. So let's take a look at the problem. Okay, you bought a new plasma TV on your Visa credit card. The cost was $4,999. Unfortunately, you lost your job and you are unable to make any payments on your credit card for 2 years. The credit card charges 17.9% continuously compounded interest. How much do you owe after 2 years? Okay, so if you imagine, okay, so this is going to be f of t equals a e to the rt. Okay, so a being how much is initially on your credit card, that is $4,999. Remember that e is just a number, so you don't have to sub anything in for that. Now the rate is 17.9%, but I need to convert that to a decimal, so that's going to be at 0.179. Okay, so up here I get 0.179. Now one little quick note is when we're using a equal, or if we're using f of t equals a e to the rt, that's a t, okay, t. Okay, this rate tells you whether your amount is going up or down, and it's whether it's positive or negative. Okay, so positives obviously mean growth, negative obviously means that we are going down. Okay, so in our case, we are going up, so it's positive 0.179. And then t is going to be 2 years. Okay, so if we type this in, again, on your calculator, okay, we have this log button, and then we have ln. Okay, to do e to a power, you have to hit the second button, which is up at the top on this side, second, and then hit the ln button. So if you imagine, you're going to hit second ln to get e to a power, and it's going to look like this. In your calculator, it should look like 4999. Okay, second e, and so you should get e, and then to a power of 0.179 times 2. Okay, so 0.179 times 2. Okay, and what you get is your final answer, and that would be $7,150.88. Okay, so as you can see, after 2 years, you have accrued a lot of interest that you will have to pay off for your credit card. All right, another thing that we can use continuously compounded interest equation for, so that y equals ae to the rt, is for population growth that's growing continuously. So for example, this bacteria in a lab, at 5 p.m. when he left, there was 153 bacteria. When he arrived at 7 a.m. the next morning, the bacteria had grown and is now 10,750 cells. What is the bacteria's rate of growth? Okay, so let's sub in what we know. 10,750 is how many we ended up with, so that goes in for y. We started with 153, and then we have e. R is what we're going to be solving for. That is the rate, and how much time, how many hours went by. Okay, so from 5 p.m. to 7 a.m., that would be a total of 14 hours. Okay, so those are parentheses. Okay, all right, so I'm going to solve for r. So the very first thing I'm going to do is I'm going to divide by 153. Okay, that's a 1, by the way. Divide by 153 on both sides. So if I do that in my calculator, I get about 70.26 equals e to the 14r. All right, so now we have e to a power, and so to solve for the power, again, I need to do a log of both sides. Okay, but the good thing is that instead of doing a log, now that I have e, what happens is I can actually do an ln. So if I do an ln of both sides, okay, this ln cancels the e out, and so what I'm left with is I'm left with the ln of 70.26 equals 14. Okay, 14r. Okay, so this ln is very powerful in that it cancels out my e to a power. So then I can just go through, and again, on your calculator, the log button, right below it, the ln button. So we're going to type in ln of 70.26, and we get 4.25 equals 14r. Last step, divide by 14 on both sides, and I get about 0.303 equals r. And so if you imagine that is in decimal form, so my actual rate is equal to 30.3%. Okay, so that's how you solve for things in the exponent when dealing with e. Okay, so we're going to be using the ln to cancel that out. Again, if you're not getting the same numbers as me, make sure that you check in with me so that we can figure it out. All right, so just to reiterate what we did on the last problem, we used the same equation, just in a little bit different form, to do population growth and decline. So for example, I did P equals P naught, this is called P naught, which is the initial population, e to the RT, just like I did. Okay, this is very similar to y equals AE to the RT. Same thing, just a different kind of concept that we use for it. So let's look at one last problem. The world's current population is 7.2 billion people. It is estimated that by 2050, there will be 9.6 billion people who inhabit the earth. At what rate is the world's population growing? Okay, so since both of these are in billion, I'm not going to write out billion. I'm just going to understand that this is 9.6 billion and this is 7.2 billion. E to the R, Now let's see. 2050, how many years is that until 2050? So I do 2050 minus 2017, and I get 33 years. Okay, so just like last time, I'm going to divide by 7.2, divide by 7.2, 9.6 divided by 7.2, 1.33. Okay, e to the 33r. Okay, and then I'm going to take the ln of both sides, and the ln is going to cancel with that e, so I get the ln of 1.33 equals 33r. Let's see, what is the ln of 1.33? In my calculator, it tells me that it is 0.285. Last step, just divide both sides by 33. And I get that the r is equal to 0.0086, which tells me that the rate is 0.86% per year. Okay, as always, if you can't set up these equations or if they don't make sense, make sure that you come ask me. And as always, thanks for watching.